So far we've been playing with these linear equations just numerically. I couldn't help but get a little bit ahead of myself right from the beginning and say that equations can actually be drawn as lines on this xy coordinate plane. That's why we had the xy coordinate plane in this section. So if I have this xy coordinate plane and I've got number lines in all directions, this one's going to be a little messy. If you flip through your notes, you'll notice that I've given you nice, neat graphs for a lot of things. So we'd have -3 here, -3, and a 3, right? This one's a bit sketchy and weird. If I wanted to, I could have a line, a straight line on this graph, and I'm going to try and draw it. I already have one kind of worked out in my notes here. It's really hard for me to draw straight lines. So something like that. And I could have, this example of a linear equation of y equaling x plus 2. So we're going to somehow in this section figure out how to go from this to the line on the graph. And there's a number of ways that we can do this. The first way that we're going to do is the table method, and it's probably the most straightforward way if it's not the most amount of work. So basically, when we were dealing with these linear equations before, I said we always needed one variable to then solve for the other. So I can choose values of x and then solve for values of y, right? So I'm going to pick the easiest numbers possible. I'm going to pick 0. I'm going to pick 1. So if I were to sub a 0 into this equation, and I'm just going to switch colors yet again here so you can see, I'm going to show my work down here. I'd have y equaling 0 plus 2. So y would equal 2. I could fill in my table so that I have an ordered pair that this line should touch. And there we go. 0, 2 is on that line. Now this one might get a little bit messy because it's such a sketchy graph, which is why I would highly recommend drawing lines with rulers and using the nice graph paper that I've put into your notes here. So let's take a look at this. This one says, if x is 1, what is y? We can complete the ordered pair in this table. So y would equal 1 plus 2. Y would equal 3. And so what I've done is complete the ordered pair here in my table. So there's this point should be a point on that line. Now it's a little messy, but it does work, right? So this is what we're going to try and do is start with the equation and go to the graph. And the first approach is going to be like what I've just done in this really sketchy way, is the table method. So let's try these ones. Okay, so the first thing it says for us to do, sorry, we're not ready to just dive in yet. I forgot. It's always easiest if we have the equation solved for y. After we solve for y, we're going to see if there's anything particular about values we should or should not choose for x. So let's take a look at these ones. Yeah, I'll come back to this. So in this one, we want to solve for y first. So I would subtract 6x on both sides. And I'm going to do things in a bit of a funky way. So we're going to put the x term first. And kind of because I say so at this point, it's going to help for the coming sections. It's going to help later, okay? So if I put the x term first, I'd have y equaling -6x plus 6. We haven't done a whole lot, but we have the equation all primed, so it's easy to work with in the table method. So that's what we're going to do here, is just practice this solving for y. If that's the first thing that we're supposed to do, going from equation to graph, that's the first thing we're going to do. So these next 3 are examples where we can practice solving for y. We're going to have 2y. We subtract x from both sides in this, so we have 2y equaling, put the x term first because it's going to matter later on, negative x plus 4. This also poses another problem. I would like to solve for y, so I have to divide by 2. One thing that I'm going to just scribble in the notes here is that you have to divide this by 2 and you have to divide this by 2. It's sort of like distributive property. But it's division, and so it's a little bit different. So if you divide out that 2, you'd have y equaling, take this step by step, we'd have negative x over 2, right? Negative x over 2. I like putting the negative with the numerator. I'll stay consistent with that. And then this second part, we also have 4 divided by 2, or a positive 4 divided by 2. So we'd have a positive 2 there. The next thing that I'm going to do, kind of like this because I say so bit, is that we're going to practice seeing this as y equaling negative 1/2 x plus 2. So basically what I'm saying is that this bit here is equivalent to this over here. By seeing the one that's invisible in there and pulling the x out so that the negative 1 over 2 is a coefficient on the x, again, it's going to really help for later on. So let's try the last two on here. You can practice this skill. If you're not ready to go off on your own, I'm going to do these ones with you. A couple of weird things in solving for y. Put the x term first. And then this funky bit of dividing both things by that number down below, right? They both have to have terms to divide out. So I'd have y equaling positive 2x minus 6. The last one here, subtract 4x from both sides. I'd have 3y, put the x term first, so negative 4x plus 12, divide both sides by 3. I'd have y equaling, check this, I'm going to do all the fraction math in one to get that as my new linear equation. So basically what I'm saying with these is if we solve for y, it makes it easier to complete a table when you pick values of x and solve for y, because it's already rearranged. You rearrange it once as opposed to having to rearrange it multiple times as you fill out your table. The other key things is this weird thing that you're not even sure why I'm telling you to do it yet, putting the x term first, and then this distributive property. And the third thing, so there's 3 wacky things, 1, 2, and the third is writing that fraction as a coefficient on the x. All of these you can kind of work around, but if we get into the right habits of it now, it's going to pay off in the coming sections. Okay, so basically these little skills are all embedded in the coming section. So let's start with one that actually doesn't have too many of these skills in it. So stay with me on this. We have our linear equation and it says graph it. So in this one, it's already solved for y. I don't have to do that. That was the first thing to do, solve for y. The next thing we're going to do is make the table. Well, I already made the table. We're now going to choose values of x, and then we're going to solve for the values of y. So I'm going to pick the easiest numbers that I can come up with. 0 is always easy to sub in, and then I like little and positive numbers. So I've chosen these values of x. If I had a fraction, that's going to change the way I choose things, okay? This one didn't have a fraction, as the coefficient, so it's straight up, no big deal. So I'm going to show my work over here. What I'm going to do is complete this ordered pair, solving for y when x is 0. So y would equal 3 times 0 plus 2. Well, y would equal 2. So you can do your rough work over on the side. I do funky little arrows to the box. I'm going to just simply sub in whatever I've chosen for my x value. So 3 times 1 plus 2. Well, that would be 3 and 2, so 5. I completed another ordered pair. The third one, and this is just for backup, you'll see in a minute, y equals 3 times 2 plus 2, so that's 6 plus 2, or 8. So I get a third ordered pair here. Now you can, if you want, graph as you go, but these three ordered pairs, if I put them on this coordinate plane, they should line up and make a nice straight line that is this equation graphed. So the next one is 1 and 5. The next one, 2 and 8, is literally off the chart. I only actually need 2 ordered pairs to draw a straight line, but this one is kind of for backup. So it would be somewhere kind of up in here, and it is in line. So it means that I haven't made a mistake. So in the videos, this is going to be terrible. I should be drawing a straight line with a ruler. Well, I have yet to figure out how this tablet can make a nice, neat straight line. So in your notes, I'm sure you're using a straight edge or a piece of cardboard or something. We're going to connect those dots. If I could connect all three, I'd connect all three with a straight line, and I know that's not very straight in the video, and I put arrows on the end. So that is in the instructions up the top. The arrows on the end are there because there are an infinite number of answers to this two variable equation, right? These lines go on forever. All the points along the line are technically solutions to this equation. And so that's how you take your table and draw the graph. Let's try another one. So we have another linear equation here. I have a y, I have an x. It's already solved for y, and this time it has a funky fraction as a coefficient. So that fraction is going to affect what numbers I choose for x. If I don't want to graph fractions, and let's be honest, who wants to deal with more fractions in their life than necessary? I'm going to pick multiples of the denominator. And this is really just so that it works out evenly. So 0 is still a good pick. I'm going to pick 2, and I'm going to pick 4. If you decide to go rogue, you will end up in fraction land. And technically you're right, but I'm trying to avoid fraction land as much as possible. So I've chosen my numbers. This time, because of the fraction, I had to pick carefully. And I knew that there was a fraction because it solved for y. So what I'm going to do next is take and sub the values that I've chosen into my equation. Here times 0, y would just equal a -3. So I can complete my table. Technically, this is an ordered pair. If you want to put it on the graph straight away, you can. Like process them bit by bit, totally good. The next one, I'm going to take and sub in a 2. Oh, I forgot the negative in that one. So it's -1/2 times 2 minus 3. If I do this, the fraction math is wacky, and I'd have 2's canceling, or -2/2, so -1 minus 3. Take as many steps as you need to in the fraction math. I'd get y equaling a -4. And again, that would make an ordered pair that I could read out of my table here. So at 2 and -4, I would have another point that was on that line. Now, technically, you have enough to draw a straight line. But we're going to do the third one as backup and a little bit of practice on our fraction skills. So what I'm doing is y equals -1/2. I'm going to sub the 4 in minus 3. The fraction math here, you can see that's over 1 if that helps. We'd have -4 over 2, or -2 if I make some sense of all my fractions, minus 3, or y equals a -5. So that would be the third ordered pair. And like I say, it's here for backup in case I've made a mistake in one of those other ones. And you can see how like the little negative signs and stuff can definitely lead to problems. So I've got 3 dots. I'm going to take my straight edge. Oh, this is not a straight line. Oh, I didn't even hit one of them. Oh my goodness. Pretend I hit all of them and made a perfect line there. I'm so sorry. I put arrows on it to illustrate that it goes on forever. I know when you watch these, it seems like I should be able to do this better, and I can't even explain how hard it is to do, so bear with me. I'll try and not make too much of a big deal of it. But that is taking that equation of y equals -1/2 x minus 3 and putting it on the graph. Let's do another one, and I think that these are good to do in a supported way until you get the hang of it. So we have another equation here that we want to put on the graph. As a reminder, we had that skill of solving for y first. We want to know if there's any fractions. We want to know if there's anything tricky about this. And we want it already rearranged so when we complete the table, we don't have to rearrange each and every time. So we're going to take this and we're going to subtract 3x on both sides. I'd end up with y equaling -3x plus 6. This is the equation that I'm going to sub into. These are equivalent equations. Both are exactly the same and would make the same line on the graph. So I don't see any fractions. I know I'm going to pick a 0. Remember, these are the things you can choose. I'm going to pick a 1 and I'm going to pick a 2. If you want to pick 11, you sure can, but it's probably not going to fit on your graph. So showing my work, subbing a 0 in where I see an x, and solving for y. Subbing in that 0 is always easy. So y would equal 6. And if I want to, I could put that on the graph. I could put my first dot on the graph, right? The next one, very similar, but this time I'm subbing a 1 in where I see the x. -3 plus 6, y would equal a 3. So I'm going to keep going the distance on these. That would be the next point on my line. And the last one, this time I'm taking a 2 in for my x. I get -6 plus 6, I get a 0. So we know that that is a location, right? 2, 0, 2 on the x, and 0 on the y. So I'm going to try not to overthink it this time. Almost made it straight. That would be my equation graphed on the line. If you want to, you can check out my answer key. You'll see that I used a straight edge and they're nice and neat and pretty, just not nice and neat and pretty in the videos. So one more here before we switch into the other system of graphing. This time, again, we're going to have to solve for y. I'm going to do that by subtracting x from both sides. Maybe I'll just rewrite it over here because it's hard to squish it in there. So I'm going to subtract x from both sides. Oops, x's can look like y's if you're not careful. We get 3y equaling -x plus 9. I'm going to divide both sides by 3. So this one's going to be a wacky one. I'd have y equaling -1/3 x plus 3. So this has a lot of those skills that we practiced on the first page. I know because I have this funky fraction in front of my x, I don't want to pick 1 and 2. I want to pick multiples of 3 because that's going to keep me in whole number land. Okay, so subbing in the 0 is always the easiest. Y equaling negative 1/3 times 0 plus 3. It all goes away. Y equals 3. I can go the distance with this and put that on my graph. The next one, it's hard to make everything all lined up. Y equals negative 1/3 times 3. Write that on top or over 1, however you like, plus 3. The good thing I put the box around this because I was searching for what am I subbing into even here. Okay, so then I'd have y equaling negative 3 over 3 or negative 1 plus 3 or y equaling a 2. All of that work for the point of 3, 2 on the graph. And the last one, I'm going to take and sub a 6 in where I see the x. Whole lot of funky fraction math going on here, so take your time. You can see it over 1, that's negative 6 over 3 or negative 2, or y equaling 1 in the end. So 6, 1. That's also, nice third point as backup. Oh, if I don't overthink it, I'm much better. That one almost hit all the dots. It's almost straight. That is this equation graphed on the coordinate plane. So we're going to move into the other kind. Now, this is the intercept method. You don't have to do things multiple different ways, but honestly, I think having the skills of the table method is something that we're going to see when we get into other sections of this course. The other methods that we're going to talk about are actually easier, I think, than the table method because there's less to do. So we're going to take a look at the intercept method. Now, the intercept method says that for every line, there are 2 really convenient points. And we've already seen how easy it is to sub in a 0. So if I take a look at where the line touches the x-axis and the y, this would be the x-intercept at, I don't know, whatever this is, 3 and 0, right? This is the x-intercept. This would be the y-intercept. And so maybe this is also at 0 and 3. It doesn't matter what line it is. For every y-intercept, x is always equal to 0, and for every x-intercept, y is always equal to 0. And so that's where I start, right? For the y-intercept, x equals 0, and you can sub that in. Remember, subbing in zeros is easy. And for x-intercepts, y equals 0, and you sub that in. You're going to get 2 ordered pairs to then draw your line with these. So let's try these. Switch back away from that reddish color I have going on. So for the y-intercept, I'm going to set x equal to 0. Those are my rules. So I take a look at my equation and I rewrite it making x 0. That's always a quick thing. We're going to divide both sides by 3 and I get that y equals 2. So what I'm saying is that 0 and 2 is a point on this line. So 0 and 2 is my y-intercept. My x-intercept, the rule is make y equal to 0. So I write out the equation, subbing in a 0 where I see that y. It means that x equals 6. So again, I've got another ordered pair here that is on the line. So at 0 and 6, or 6 and 0, I should say, is another point on the line. And just that quick, oh, look at that, I even nailed it, would be able to allow me to draw the line with those arrows extending onto infinity. There's an infinite number of solutions. Way quicker than the table method, hey? No solving for y, no fraction bills, any of that stuff. So here we have another one. I'm going to start with the y-intercept with x equaling 0. Go to that original question and I'm going to sub in a 0 where I see the x. I'd have negative 5y equaling 15, divide by negative 5, divide by negative 5. I get that y equals negative 3. So what that's saying is that I have an ordered pair of 0 and negative 3. And I can put that literally on the graph. Okay, so the x-intercept, that means that y equals 0. So I'd recopy this. So 3x minus 5 times 0 equaling 15. That whole part goes away. I'd have 3x equaling 15. Or divide by 3 on both sides, I get that x equals 5. So again, an ordered pair of 5 and 0 is a point on the line. So I can put the 2 points on, no line or no point for backup. Oh, I'm getting better at this. That would be the equation of the line graphed on the Cartesian plane, or the xy coordinate plane. Sorry, don't usually call it that. Okay, so the last one, I always start with the y-intercept. It doesn't say yint, it says y-intercept, where x equals 0, subbing that in where I see it, and solving for the other variable. I get that y equals 4. So again, it's an ordered pair that I've been building here, and it's a point on the graph. The x-intercept, my instructions are make the other variable 0. So now I go back to my equation and I sub in a 0 where I see that y. That part of the equation basically disappears. I'll rewrite it because it gets a little bit far apart. Divide by 4, and I get that x equals 3. And again, roll it back to build the ordered pair because that tells you where you're supposed to go on the graph. And so then, whoa, a little bit of a snaky straight line. I do use a ruler when I can. That's how to put this equation on the line, or line on the graph, sorry. Okay, so one more. You can use the table or the intercept, really doesn't matter to me. I quite like the y-intercept and the x-intercept. So these are my instructions for finding the y-intercept. So it'd be 4 times 0 plus 5y equaling 20. Subbing in zeros, parts of it always just goes away. So I get that y equals 4. I think the tricky part is bringing it back to an ordered pair, remembering what you're doing here. You're finding a point on the line. The x-intercept, y equals 0. So copy it out. This time the y is 0 when you sub it in, and that part of the equation goes away. I get x equaling 5. I skipped a couple steps there. Hopefully that doesn't throw you. And again, the whole point of this is to build an ordered pair. So I can put 2 points on the graph and draw my very straight line. All right, so these are all angled straight lines. We need to talk a little bit about the fact that we have been dealing with linear equations, right? But sometimes there's some oddballs. Sometimes we have zeros as coefficients, which basically wipes out either the x or the y. We're going to take a look at these ones that are a little bit different. So vertical lines, these are examples of vertical lines. So vertical lines are of a different format. They just say that x equals something, and they're a line at that point. So if I were to graph x equaling 3, it's just a vertical line, pretend that's vertical, straight, at x equaling 3. X equaling negative 5 is a vertical line at negative 5. This one looks a little bit funky, but we need to rearrange it, and then we could see that it's x equaling -2. These are all actually a lot simpler to get on the graph, but they look really strange. Sometimes we get more comfortable doing all the work, going through all the strategies and procedures to get things on the graph. The last kind of line that we're going to talk about here are vertical lines. So vertical lines, again, have part of them missing. They're always y equaling something. Sorry, I said horizontal. Man, okay, 30 minutes in on a video and I start making mistakes. That's a bad sign. So these are all horizontal lines. They are simply lines at these numbers. So I can draw horizontal lines much neater than vertical lines on my video making. So that would be y equal to 4, y equal to -2. A horizontal line at that point. This one again takes a little bit of rearranging in order to see it's really just y equaling 3. And we could draw a straight line, a horizontal line at y equaling 3. We'll be sure to have some attention to these oddballs. They're actually easier, but their simplicity, I think, is sometimes what makes them tricky.